So let's look at problem number 3 where I have 7x squared equals 21. So remember how I said that not only do you want to isolate your quadratic term, you actually just want to isolate the variable squared. So what I would do in this case, obviously my constant has already been moved over, but I'm going to go ahead and divide both sides by 7 here, okay? So then I'm going to get x squared equals 3. So that is very, very important that not only your quadratic term needs to be isolated, but actually just the variable squared, because I want to be able to do the inverse of squaring, which is taking the square root. So x is going to equal, now 3, you can't break 3 down. It's a prime number. So then it is going to be positive square root of 3 and negative square root of 3. So that one was relatively simple with my solution there because there was nothing I could break down with it. So let's look at number 4. Number 4, I have 2m squared plus 10 equals 210. So here I'm going to subtract 10 from both sides, so I get 2m squared equals 200. And then I'm going to divide both sides by 2. Because I need to get my variable squared alone. I need that isolated. Now I'm going to do the inverse of squaring, which is square rooting. Square root of 100, easy peasy lemon squeezy. So I get 10 and negative 10. So don't forget for all of these, it's the positive and negative of it. Okay? And I do have my very last problem of 2x squared equals 64. So I'm going to divide both sides by 2 because remember we want my variable to be isolated, my variable squared to be isolated. So now I get x squared equals 32. So I'm going to take the square root. So I can break this all down, 8 and 4, 4 and 2, 2 and 2. The 4 can break down into 2 and 2. So now what I'm looking at, because again it's a square root, so I need them in groups of 2. So that's one group of 2, that's another group of 2. So what I'm taking out here is I'm taking out 1 2 and another 2, and I need to multiply them together. So whatever you take out, those numbers you're going to multiply together. So I'm going to multiply this 2 by that 2. So 2 times 2 is 4. And then I get the square root of 2 because this guy chickened out. He did not want to jump. And then you would also have negative 4 square root of 2. Again, the other way to go about this is if you have x squared equals 32 and you square root it, x equals the square root of 32 and negative square root of 32. But then you'd have to break it down. And so some people might look at it as, oh, well, that's 4 times 8. Oh, but 8 can be broken down into 4 and 2. And then I know I can do square root of 4 times square root of 4 times square root of 2. And square root of 4 is 2, square root of 4 is 2, and then I've got the square root of 2. So that's how I get 4 square root of 2. And then obviously negative 4 square root of 2. So again, ladies, you have to decide which method works better for you. Do you want to just break it down to its prime factorization and group them accordingly? Or do you want to break it down by perfect squares within the square root? Again, it's totally your call, whichever one you feel more comfortable with. And if you need more examples, I'd be happy to show you more of like breaking things down in class. Like some people might say like, oh, the square root of 27. So the square root of 27 I can break down into 9 and 3, and then 3 and 3, and I need a group of 2, so I get 3 square root of 3. Or you can look at 27 as that's 9 times 3, so square root of 9 times square root of 3, and that's 3 radical 3. It's really to each his own. It does not matter which approach you want to take. What matters is what you feel more comfortable with. So always keep that in mind, and if you have any questions or need any advice on how to approach it, please feel free to ask me, okay? And then now, enjoy solving by square roots.